Welcome to Cheenta School of Statistics and Data Science. Today we will be doing problem number 19 of GATE 2022 statistics paper. The problem says that x1, x2, xn be a random sample from the population f x theta, where theta is a parameter. Then we have to check whether which one of the following statements is not true. So we are given that x1, x2, xn is a IID random sample from the distribution of f with the parameter theta. We have to check the four conditions whether they are correct or not. So let us first check the option A. So the joint PMF of the random sample can be written as e to the power minus n theta divided by product of xi factorial into theta to the power summation xi, where theta greater than 0 and xi belongs to 0, 1, 2 up to infinity, and for all I equal to 1 to n. So this can be written in the form of exponential of ln theta into summation xi minus summation of ln xi factorial minus n theta, where ln is log base e. So we can write it as exponential of tx curl into u theta plus wx curl plus v theta, where tx curl is summation xi, u theta is log theta ln theta, wx curl is minus summation ln xi factorial, and v theta is minus n theta. So observe that t and u are the non-constant function. T is summation xi and u is ln theta, which are non-constant function of the sample and the parameter respectively. The support, that is the value of the samples where the PDF is takes the positive value, is independent of theta, as xi equal to 0, 1, 2 up to infinity is does not depend on theta for all I. And the parameter space here, theta is greater than 0. Theta greater than 0 is this parameter space, is an open interval in R. So by the checking the three conditions and writing the PDF as in the form of exponential family, we can say that the family is in the OPF, that is one parameter exponential family, and hence tx curl equal to summation xi is complete and sufficient for the family. Hence option A is true. Now to check option B, we first write the joint PDF of x curl, the sample, as follows. The PDF can be written as 1 by root 2 pi to the power n into theta to the power n into exponential of minus 2 by theta square summation I equal to 1 to n xi minus theta square, for theta greater than 0 and x curl belongs to Rn space. So this can be written as 1 by root 2 pi theta whole to the power n into exponential of minus summation xi square by 2 theta square plus summation xi by theta minus n by 2, which can be written as product of two functions g and h, where g is the function of tx and theta and h is a function of x, the sample only, independent of theta. At g tx curl theta is 1 by theta to the power n exponential of minus xi square by 2 theta square plus summation xi by theta, and the remaining part goes to hx, which is independent of theta. Hence, from Neyman-Fisher factorization theorem, we can say Tx is sufficient for the family, where Tx is summation xi square and summation xi. Now observe that expectation of x summation xi square is coming out to be 2n theta square. We can write expectation of xi square equal to variance of xi plus expectation square of xi, which is coming out to 2 theta square. And expectation of summation xi whole square is coming out to be n into n plus 1 theta square. We can write summation xi is n into x bar, and from that we can write it as n square into expectation of x bar square. So expectation of x bar square is coming out to be variance of x bar plus expectation square of x bar. So we can consider a function ht as 1 by 2 n summation xi square minus 1 by n into n plus 1 summation xi whole square. So the expected value of first part is theta square and second part is theta square also. Hence the expected value of the difference, that is the expectation of ht, is theta for all theta greater than 0. But observe that ht is not identically 0, as for different samples ht can take different values. It will not identically 0. So from the definition of completeness, we can say tx is not complete, hence b is not true. Now to check option C, we define monotone MLR as a family fx theta, for theta belonging to the parameter space omega, as a monotone likelihood ratio property in statistic T if for theta 1 less than theta 2, where theta 1 theta 2 belongs to the parameter space, the ratio fx curl theta 2 divided by fx curl theta 1 is non-decreasing function of t for the values of x with at least one numerator or denominator greater than 0. So here for the family fx theta equal to theta into x to the power theta minus 1 for theta greater than 0 and x lies between 0 to 1. Consider theta 1 less than theta 2. Uh, they both belong to the parameter space. Then we check the ratio. It's coming out to be theta 2 by theta 1 whole to the power n into product of xi in whole to the power theta 2 minus theta 1. We denote the product by tx and see that for theta 1 greater than theta 2, the ratio is an increasing function of t. So tx is non-decreasing, and hence from the property of MLR we can say that family is the family has the MLR property in statistic product of xi. So option C is correct. Now to check option D, we define ancillary as a statistic W is ancillary for a family fx theta for theta belong to parameter space omega if the distribution of W does not depend on the choice of the family. That is, the distribution of W should be independent of the parameter. So here for the given family, fx theta equal to 1 for theta lies between x, for x lies between theta to theta plus 1 and theta greater than 0. Xi follows IID uniform 0, uniform theta theta plus 1, and xi minus theta we denote it by yi. So this follows IID uniform 0 1, and we can define y order n equal to maximum of yi for I equal to 1 to n, and y order 1 equal to minimum of yi for I equal to 1 to n. So as individual yi does not, the distribution of individual yi's does not depend on theta. So the distribution of y order n and y order 1 will also not depend on theta, and hence their difference will also not depend on theta. So y order n minus y order 1 is eventually becomes x order n minus x order 1, and this has a distribution independent of the parameter. So we can say from the definition of the ancillary statistic that x order n minus x order 1 is ancillary for the family. So option D is correct. So by checking all the four options, we say that we check that option B is not true. That is, option B is the only correct option. So that is all for today. Thank you for watching. I will see you in the next video. Stay tuned and stay blessed.